Hello everyone, welcome to my YouTube channel. Yesterday we learned some basic logarithm properties. So today I shall be teaching you, first of all, I'll be teaching what is the difference between a common base and a natural base. And second thing, we shall be starting the properties of logarithms from today. Okay, so first please write the heading as common base and natural base as I've written. So first, let, let me teach you what is common base first. So if a log is represented like this, if the log is written like this, log x to the base 10, we can also write it as log x. Okay, so which means this is a log with common base. Base, what is the common base here? 10. So usually common base for log is 10. Okay, so log x to the base 10 can be also be written as log x. This sounds okay. Now let's understand what is natural base. Okay, so so if a log is written like this, log x to the base e, where e is the natural base, we call e as natural base. We can write this as this also as ln of x. Okay, we can also write log x to the base e as ln of x, where e here is the natural base. So you may be wondering what is the value of e here. Okay, so value of e is actually an irrational number, okay, whose approximate value is equal to 2.7182. So you can just remember it as 2.71. 2.7182. Here actually e is an irrational number. Okay, so let's write some examples. Okay, so yeah, some example under common base. So suppose if I ask you a question, if I give you a question called log 5, so then what is it representing? So as I told you here, if there is no base written here, then you should assume it as 10. So since there is no base written here, so we can assume it as log 5 to the base 10. So what does it mean? Please write a note down here that it means that if there is no base, there is no base in log, then by default the base is 10. So I hope you understood this. Please write a note that suppose if there is no base, since there is no base here, then by default it means that this logarithm's base is 10. Okay. Okay. Another example. If there is something, if the question is like log 10, so what does this mean? It means that log, since there is no base, by default the base is 10. So log 10 to the base 10. So as I told you in the previous lecture, that what does this mean? That what should be the power of base so that it becomes a number? So 10 to the power 1 is 10. So the answer to this question is 1. It's simple. Okay. So now some examples under natural base. Examples. Okay. So if I there is a log is this. Okay. Log 2 to the base e. Log 2 to the base e. Then it means that we can also write it as We can also write it as ln2. So next, like if the question is written like this, so lne. So what does this mean? It means that log e to the base e. So e is power 1. If we keep the power e, if we keep the power of e as 1, then we get this number. Okay, so the answer to this question is 1. So another question, what is ln1? What is ln1? If you are not able to answer in this format, then convert it into this format. Okay, so we can write it as log 1 to the base e. What is answer to this question? I hope you found out this answer. So log 1 to the base e. So as you know, like from the exponents, from the exponents, you know that anything power 0 gives 1. Okay, anything power 0 is actually 1. So the answer to this question is equal to 0. So ln of 1 is nothing but 0. Okay. Okay, so now we move on to properties of log. Okay, so property number 1. What is property number 1? Property number 1 says that log a to the base b, where log a to the base b is only defined when log a to the base b is only defined if a is greater than 0, which means the number should be greater than 0, and b, the base should also be positive. B also should be greater than 0, and b should not be equal to 1. Why b should not be equal to 1? Because anything power 1 is 1 only. If you keep ones power 1000 also, then you will get the answer as 1. So that's why the base should not be equal to 1. So important thing to remember that all should be true. All these three should be true. All should be true. Okay. Okay, so now let's move on to some examples. Okay, uh, some examples based on this property. So first example, log 8 to the base minus 2. Okay, so just keep writing the answers, just keep writing the answer solutions for this by comparing this with these conditions. First verify whether all these conditions are satisfied. Suppose I'll just explain the first question. Okay, so since base should be always be positive, but here base is actually negative. It's negative, which means it's less than 0. So the solution to this question is it's not defined. You cannot answer like that. Another example, just keep writing the questions. Okay, first I'll write all the questions and then give solutions one by one. So you can just pause the video and try to answer all the questions which I'm writing here. I request you to pause the video right here and answer all these questions. I hope you answered all these questions. It's pretty much simple, okay? I'll just write the answers for this, okay? So here, first verify the conditions, okay? Log a to the base b is only defined when if a is greater than 0. Check if a is greater than, yes, it's greater than 0. B is also greater than 0, but b should not be equal to 1. But here it's equal to 1. So this is not defined. It's not defined. Next, here a should be greater than 0, but a here it's negative. The number here is negative, so it's not defined. What about here? A is positive? Yeah, a is positive. B is positive? Yes, b is positive. But b should not be equal to 1, but b here is equal to 1. That's not defined. Some people may get the doubt that uh, once power. Some people may get the doubt actually that if you keep the power of 1, you get satisfying this answer. But see, the answer, if you think the answer maybe if you keep 1's power 1, it's 1, so the answer will be 1, but that's not the case actually. See, if I ask you that once power 1000 is also 1000, once power 1000 is also 1, no? So why not you can write the answer as 1000 also, no? That's not, so that's why it's not defined, okay? So here a, check the first condition, a is greater than 0. No, a is equal to 0, so it's not defined. Then log 1 to the base 3. So as you know, according to experiments I told you here, anything power 0 gives you 1. So the answer to this question is not defined, it's actually 0. Okay. I hope you understood all these concepts. Okay, so this example is kind of important, so let me teach you this question. Let me tell you how to solve this question, okay? That find the values of x for which log of x square minus 3x plus 2 to the base 5 is defined. So he's asking you to find the values of x, okay? So yeah, it's basically the quadratic equations. To solve this question you just need the 10th knowledge of solving the quadratic equation. So that is splitting the middle term, okay? X square minus 3x plus 2. According to the condition here, the number should be greater than 0. A should be greater than 0, okay? So according to the condition, write it as x square minus 3x plus 2 is greater than 0. Okay, it's just like splitting the middle term, okay? So you can write it as, how should we split the middle term? So you should get the answer like, if you should split this middle term in such a way that by multiplying you get this answer like 2x square, and if you add them both you should get this value, okay? So I can split it as x square minus x minus 2x plus 2 is greater than 0. So if you add these both terms you get minus 3x, and if you multiply, so minus into minus becomes plus, you get the answer as 2x square. That is the same case if you multiply this with this, so constant with the x square term, you get 2x square. So you can write it as x minus 1 into x minus 2 is greater than 0. So just plot these values on a number line. Okay? Where there are separate values for x are x is equals to 1 and x is equals to 2. So plot this number line as 1 and 2. Okay, so according to this, since there is a greater than symbol here, so we start from right side as plus minus plus. Okay, so as you can see, let's write it clearly that x is equals to 1, it's actually greater than 0, and here x equals to is actually greater than 0. So I can from I can write it as it goes from this side. You can be able to understand this clearly when I teach you the wavy curve method. Okay, so don't get tense by saying what is this, what is I'm not able to understand. It's just a simple thing. I'll teach you in wavy curve method. Okay, so which means you can tell me that x belongs to, sorry, this is actually the belongs to symbol. I'll teach you what are the symbols used in the math. Okay, so x belongs to minus infinity to 1 union 2 to infinity. These are the values of x. This is actually the answer. Okay, so I hope you understand I hope you understood all the concepts which I taught you today, except for this question. You may get stuck at this point of question. Okay, so you'll get to understand when I teach you wavy curve method. Don't get tensed. Okay, I'll teach you everything. Okay, so if you understood everything, then please do like the video and subscribe to my channel. Thank you.